Hello and welcome to the New Space Vision podcast sponsored by LiveView, where we discuss new space technology, finance and innovation with executives, founders and more exciting people from the startup and new space ecosystem. I'm Sam Shivara.
And I'm Daniel Seidel, and together we are the founders of the Earth observation company LiveView and New Space Vision. Today's guest is Karthik Gollapudi. He's the founder and CEO of SIFT. I have to say, I'm personally really excited about today's podcast because it's about how to apply AI analytics in understanding the health of aerospace, defense, and robotics hardware. And we learned this from a former SpaceX employee who worked in the system, which I also really like. And yeah, welcome to the show, Karthik. How are you?
I'm great. Thanks for having me. Excited to have this conversation with you guys.
Yeah, we always start with a personal story behind the company and founding the company, right? So yeah, tell us a bit quick about your journey and how you landed in the space ecosystem.
Yeah, of course. So, it wasn't as targeted as I might think, but I think unintentionally the signs were always there since I was little. So I grew up right outside of JPL, Jet Propulsion Laboratory in Pasadena, California. So I actually saw the Mars rovers, and I was always interested in robots and hardware, and I did all the first robotics competitions. So I was very much into hardware, but I never really thought much about space. And when I graduated out of undergrad, I interviewed at a few different companies like Palantir, Stripe, SpaceX, etc. And there's just something in the air when you go to SpaceX. It's that it like pulls you. And I think it's still there. I think it was there back in 2018 when I joined. I think it's still there today. There's just something so exciting about the mission, and people are all so excited about what they're doing and happy. And I think the biggest thing is that people never talked about their life outside of what they're doing and building. It was not like a work-life balance type of a thing. It's more like, hey, this is what we're building. Do you want to come build this with us? It's like, come play my Legos with me. So I think that's what pulled me there in the first place. And then my background was initially started doing some internal tools and then some simulation software, ended up becoming the simulation lead for the Dragon program, and then eventually just started becoming one of the flight software leads for the Dragon flight software team. And Dragon's a capsule that carries astronauts and cargo to the space station. So had a really fun, just over 4-year time there and learned a ton. Honestly, the best place to ever start your career.
Yeah, that sounds super exciting. And also to all the listeners, if you want to go back into the archives, we also have a few other SpaceX alumni, including Hans Königsmann, a great episode I encourage everyone to listen to. So obviously everyone, I think, who's listening to this podcast knows about the Dragon capsule and the importance of also getting things right when sending this into space, and also even more important to also bring it back. Did you also meet the other team members of your company SIFT at SpaceX, or where did you meet them?
I did. It's kind of funny because Austin, my co-founder, him and I both went to the same undergrad. We were the same year, almost the same major, like slightly different minors, but effectively the same major. And we actually never met at school because I think the way it works is like if you start that curriculum even just one semester before the other person, then you're always offset. So we never actually met each other there. But then he ended up interviewing me for SpaceX, and we initially were on the same team, worked together for a short while, but then that's when I ended up switching teams to this simulation team, and he was one of the leads on a lot of the internal manufacturing tools. So think of it as, it's called the MES, Manufacturing Execution System. Think of it as like a Lego manual, but for building rockets and the Dragon capsule. So we kind of diverged there, but then I think there was always like a mutual respect of like high achieving, wanting to do a lot of like more ambitious folks that were within SpaceX of like similar backgrounds. And we stayed in touch. And then in 2022, he had actually left SpaceX in I think 2020 or 2021 and went to Riot Games. And then he's like, hey, Karthik, I've been on vacation for a year at Riot Games. Let me come. I want to come back to like a hardware company. And him and I were talking about some of the opportunities and some of the companies. And I was telling him, hey, there's this really big problem in the ecosystem where if you notice, at SpaceX, the way we build a lot of hardware is very different than the rest of the world. Like we build our hardware the way that most people build software. And what I mean by that is like very iterative, a lot of iterative, like you make a lot of changes, but then if you make a lot of those changes, you need to have like a system that percolates that risk and shows you what things break every time you make changes. Yeah. In the software world, this is called CI/CD, continuous integration, continuous deployment. And this CI/CD philosophy that's in the software world, SpaceX brought it to the hardware world. And I was saying to him, hey, you should like go build, because I knew he worked on some of these tools for Starlink actually just before he left. And I said, you should go bring this for the rest of the ecosystem. Because for me, on my mind was actually the 737 MAX. Remember the planes that were crashing?
Yeah.
And that's when I realized that, like, hey, someone here at SpaceX that understands how we build hardware reliably, somebody needs to bring these ideas and philosophies to the rest of the world. And I had no intention of leaving. I was actually living my best life. I was a responsible engineer for 2 of the Dragon missions right around that time we're having that conversation. And he was like, oh, that's funny because 4 different companies are trying to hire me to go build this internally.
Oh.
And I thought it was an interesting data point. If everyone needs this, everyone's trying to build this, why doesn't someone just build it once?
Great market validation.
Exactly. So we ended up speaking to, I think, 17 companies and realized that all of them, I think it was 14 out of 17 needed something within the next year. And that was enough conviction that I said, hey, let's go build this. Because I think for Austin, he knew how to go build this, but he'd never been a user of these tools. Whereas I was a big user of these tools on the flight software team. So that's when we ended up leaving, ended up starting a company. And now we're about 4 years in, about 90 something folks, 70 million raised. Google's our biggest investor. And we're just busy building and growing. And we work with everyone from early stage startups to defense primes, like some of the vehicles on the Artemis mission to the moon. That's actually connected and running on SIFT.
Yeah, you definitely have a fast track into what looks like a lot of success, because also in your undergrad you did computer science, right? And
I did, yes.
Like what was your hardware connection back then, and how did you learn the space stuff?
Honestly, it's I feel like you learn everything on the job. Like I don't even know, like undergrad. I have nothing against undergrad. I thought it was a lot of fun. Enjoyed that time. But I mean, everything we learned was from being there, being agile, learning from other of your peers, reading a lot. It's just like a new subject in college. And you're going into each class and each subject fresh without that historical context. So I don't know. I think it's like what you learned is maybe like some of the ideas or ways to learn quickly in undergrad and high school, but I don't know if anything that we learned in undergrad directly translates to things that we did on the job.
I mean, that totally makes sense. And I mean, we're going to also touch a bit, the urgency you have seen at SpaceX you transform to your company. But before we do this, maybe how would you explain a 5 years old what your company is actually doing?
Yeah, the way I would describe it is, I don't know if I would say 5-year-old, but I could definitely explain it to like somebody who's had a blood test. The way I describe it is kind of like a blood test. When you go to the doctor, they do a blood test to make sure that all these different biomarkers for your health, your cholesterol, your blood sugar, your vitamin levels, all of that. You want to measure those to make sure that you're healthy. And then it diagnoses you to say, hey, this is broken. This is not, you need to go maybe take some more vitamins. You need to go take your iron is low. So let's go take some iron pills. Like that blood test, SIFT is that blood test. Mm-hmm. And the big thing is that if you only got a blood test once a year, then you can go to a whole year without realizing something is wrong. And like when you're talking about something that's very mission critical, you might have humans on board, like these planes. You can't wait a whole year to find something wrong. You would have had 1 million flights by that point. And that's what happened with the 737 MAX. They found out things that were breaking in the field and the planes were crashing. And really the way that you actually want to do this is like, what if you could have a continuous blood test that's always checking to see, hey, your blood sugar is spiking, your iron is a little low, or you have this other thing that might be indicative of like some other bigger concern. SIFT is literally just that blood test, but it's like a continuous version of that blood test. So we can ensure that your hardware is always healthy. And the reason why that's really important is because let's say you're making a lot of changes to your hardware. Let's say you're iterating on the hardware, you're changing the plane, the shape of the wings, you're changing the engines, you're adding new components. If you only measured your blood test once a year, then a lot of things can change before you realize, oh, something broke. And then you have to go figure out, what did we change over the last year that caused this thing to break? Yeah. Whereas if you're continuously measuring that blood test, then as soon as you make that change, you see something, this broke something. Let me take it out and see if it gets back to normal. So that's actually why SIFT exists, which is how do you continuously monitor the hardware so that people can continuously iterate on it.
Yeah, super cool. And how would, like you mentioned, like this has been an integral part of SpaceX DNA and way of working for a long time. But a lot of the customers you're selling now to, how would they solve this right now? Because I would just hope that an Airbus, to not now take Boeing as the example, is doing some kinds of test while they develop their hardware, right? Or some of the other customers you have. What were they doing before using SIFT?
Yeah, I mean, well, yes, I want to say that they are, but I mean, Boeing was crashing planes and killing people. And then their Starliner was stranding astronauts in space. So yes, I want to say they were doing something before, but clearly it wasn't good enough.
Working. Yeah.
And it wasn't working properly. So, and this is on all the new vehicle programs. A lot of the older vehicle programs are, one of the things is that they were able to get away with fewer tests because they weren't making as many changes. Whereas if you think about a lot of the new hardware now, it's very software rich, and software you can iterate a lot faster. And a lot of the issues that they were having, like the Starliner mission back in 2019, that was related to some of the software. Actually, it was a mission elapsed time. It was like a software bug. Or if you take the 737 MAX, that was autopilot software. So a lot of things that are breaking is actually that the hardware is changing, and the way that they were doing, like when you're in the manual world and weren't making as many changes, it wasn't as big of a problem. But now they have a lot more software rich hardware, then things are breaking. So to say that how are customers solving this, they actually aren't solving this.
Yeah.
And that's why we're building this. If you want to talk about maybe like a more like a little bit newer company, like some of these fast growing startups, the way they were solving this was actually they would put together the ones who do have something. What we've seen is like a homegrown system, like usually pieced together like an open source database or along with some like data visualization tools. And then it's still a relatively manual process, but it's not necessarily like to the same fidelity and quality of like what we're doing in SIFT.
Yeah. And you're taking ultimately as input variables telemetry data from sensors, or
Exactly.
and also from the hardware components itself, correct?
Exactly. Yeah. So telemetry is basically all that sensor readings. So it could be like temperature, pressure, those types of sensors, but it could also be like logs out of the flight computers. And the powerful thing is, how do you stitch all those together? So like one of our customers, that's a satellite company, pretty large geostationary communication satellite company. They had their logs going into Splunk. They had their time series data going into both Timescale and to InfluxDB. They had their video sitting on the device. They had some other audio files on that device. It's like everything is in different places. And in order to figure out why something went wrong, you have to basically go pull the data from all these different sources. And then on the bigger issue on top of that is that they all have slightly different timestamps, because if you're looking at things that happen within the frame of like milliseconds, if the clocks aren't all synchronized, then, which is hard when you have all these different devices, like you have the video recorder and you have the log on the flight computer, they're all different clocks. So how do you like align all this? So if you see a spike here in the data, and you see an issue in the logs, like how do you know that you have to like basically apply all these manual time offsets? So with SIFT, all that goes into one place. It all gets time aligned. It all gets organized, and you can pull up one big panel like you can see on our website, and you can see all of it in line with each other.
So one connection I see is our like one of our founder reps in our board, Mirko Novakovic. He has an observability platform, -0. So he sold the first observability platform in Stana to IBM for $500 million, and then he started -0 and is now also a unicorn already. So that's on the IT side. So we have some touch points with him. And what I like about you, like I don't know of anything similar right now which comes to my mind to what you are doing, right? And what I like on your website, right, you have this test, analyze, investigate, and action, and you see all the tools, right, from GitLab, PowerPoint, Grafana, MATLAB, Jira, etc., and everything in one platform. This sounds like very handy, but it also, I mean, we are also a data company, an AI company, so it also sounds like a lot of groundwork to connect all these systems, right? So how did you come up with that?
Come up with the idea of all this? Or
but also like the first versions of it, and like because I can see if you go to different companies, they also have different systems in place. So do you connect to these also legacy systems, or is it easier to directly go and connect the hardware?
Well, we can connect to all of it. I think a lot of times people think that all these different systems have different formats, but if you unpack it all, at the end of the day, everything is just a timestamp and a data point. So it all distills down to the same thing at the end of the day. The part that gets tricky though is actually for the space companies, because it's not just a timestamp and a data point. You have multiple timestamps per data point. Like if you think about gravitational time dilation, which like we have a customer that they actually part of this Artemis mission, right? So when they're going around the moon, they have 6 different timestamps. They have the Earth timestamp, they have the moon timestamp, they have the vehicle timestamp, they have some of the deep space network timestamps. Like try to put that into an open source database.
Yeah.
So we basically had to build our own database to work with all this stuff.
Crazy.
Did you want me to explain gravitational time dilation for the audience, or?
I think everyone who wants to figure out what that is can Google, but it's super cool to hear. But you've mentioned a lot of like space examples, and it is logical. You have been coming from the space industry, but is the space industry as a customer segment your biggest market you're selling into? Because obviously there are sometimes much larger markets out there, automotive, aerospace, and large. So are you, exactly. Where's your focus right now in terms of customers? Because that sounds like a very specific problem. I bet BMW never had that problem with the 6 different timestamps in the sensor.
Yeah, I don't think they do.
Not yet.
Toyota probably does though. Toyota, I don't know, but a lot of people don't realize this, but Toyota has like a whole space division. And if you look at the Toyota Lunar Rover, it's like the coolest vehicle. It's because it's a pressurized Lunar Rover. It's not like the type where you ride it with your like spacesuit. It's a type where you can go inside and it's pressurized, I believe. And it looks like an FJ Cruiser, kind of like they borrowed the headlights from the FJ Cruiser. Super cool. But yeah, most of our customers don't, outside of aerospace, don't have to deal with gravitational time dilation. So I would say our customer base is roughly half in aerospace, and then the rest is split across like aviation, defense. We actually signed a pretty big defense deal last week. So aviation, defense, robotics, energy. Energy has actually been a growing space right now. So there's definitely, let's say, more and more demand in non-space sectors. I think a lot of it just our network is heavily saturated with SpaceX by space because of SpaceX.
But I think it's also a good sales pitch if you can say, hey, like we have SpaceX technology, how they build hardware, and you can apply it in your XYZ robot or whatever, right? So I think like that opens up the discussions, right? Or do you use it like this? Or?
Well, I think no, because one, you don't want to say that you took tech out of SpaceX, but two, what we've actually developed now has diverged quite a bit from what we use and have at SpaceX. I think there's like a lot of general ideas and philosophies of what we learned at SpaceX, but none of it was actually productized into like a specific thing saying this is it. There's actually quite a few different like ideas and philosophies around, like if you think about people going from waterfall to agile software development, and then you have tools like Jira, which has like Bitbucket and CI/CD and all those things that are within it. I would say what we're doing is we're building tools to complement like a philosophy of how to do hardware engineering, like software, but it's not like it's a one-to-one copy for what we had originally at SpaceX.
And then also, is it the business model? Is it like a standard SaaS subscription, or because I can see on the defense side, etc. There's also there's a lot of maybe I don't know if you have forward deployed engineers, or how we are embedded. Maybe you can share a bit about the business model and how customers can buy your solution.
Yeah, of course. I mean, the best way to buy it is come to our website, sign up, and chat with our team. But the way it works is that it's kind of like a consumption base, like any other like database product. So I think it's actually less SaaS, more infra. So I would say it's actually much closer to like you getting a database product, and then it has like an application layer on top of that database. But think about it as very much more like you're signing for AWS, and you pay based on how much of you're using, how much data you're sending.
Yeah. And is it really like a self-service? Is it possible, or do you have to talk to someone?
Right now, we have people talk to people. We're making it increasing self-service, but I think it's just a matter of like, there's like a certain amount of like polish, finesse, onboarding that you really want to do for it to be purely self-service. Otherwise, it's hard for people to get as much value out of it. And I think that's just like a company maturity thing. As we continue to develop it further and further, we'll make it more and more self-service.
Yeah. Before going into maybe what the product can become and also what maybe other industries you can like serve with the product, one question I'm having, because you've raised a lot of money and I know that VCs love a good analogy. So if you what software focused company in the world of telemetry would you say is the closest analogy to what you're building for hardware?
I would say one of these observability companies. So think like Datadog.
Yeah.
Datadog is probably the closest analogy.
Yeah.
Also a European founder, right?
To be honest, I don't know, but like I know that
I think he's French.
Then Mirko Novakovic said our founder rep had a good commercial fight with Datadog.
And exactly again. He was really regretting that he sold it, but he's also talking on podcasts about this, and now that's why he started the second observability company, Dash0. So one thing they are doing, which was a surprise, is they now deployed the agent on top of the observability data, right on top of the telemetry. Like, do you also already have this deployed in your products? Or how do you think about it?
Yeah, I don't want to go too much into our roadmap, but at a high level, what I'll say is that we tell our customers, how do you build hardware like software? And if you think about the way that the software is being built is changing right now with AI. So a lot of our roadmap is focused on how do you build hardware like software in the AI era and bringing some of those modern software development techniques to the hardware world.
Yeah.
I can't get too specific into our into what we're building right now.
But there will, I think every product in the world will have an LLM interface at some point in time. So I could imagine that it's going that direction. But you've also, prior to this conversation, have hinted that you see also other areas where your product can potentially help with really increasing the iteration speed of development in R&D and then also production. You've also hinted that you see a lot of analogies between biology and space, and we didn't double click on that earlier because we found it to be an interesting topic to talk about now. Because so far, aerospace and hardware, how could a product like yours also work in the field of biology, for example?
When I was actually talking about that, I was thinking more about the advances in biology are going to enable a lot of our human expansion into space.
Yeah.
So less about SIFT, more just macro.
Yeah.
So what I was going to go and describe to you was actually that if you think about a lot of gene editing and what people are doing with IVF today is they're able to select for, they'll do is fertilize eggs and then they'll choose the eggs that have the best traits. So they avoid negative traits and they choose the traits that are most beneficial. And what I'm going to start seeing is, what I think very soon is you're going to start seeing people do gene editing to remove the traits that are problematic. That, like, for example, my no matter what I do, just all sides of the family, all the eggs are going to have some predisposition to diabetes. Yeah. It's just like South Indian. It's just like a thing that's in our genes. And what we'll do is, I think you're going to start seeing us within 5 years starting to remove those traits. And then what I think is going to be interesting is that within 10 years, we're going to start adding traits, and it's going to be a lot more normalized to say, hey, we want to add this natural resistance to certain types of diseases. And then what I think we're going to have within 15 years is people starting to add superhuman traits, like traits that would never have existed in humans. So for example, let's say you're a kid that's actually born on Mars. Well, could we actually make it so that you're born with increased radiation tolerance? If you're born on the moon, can we make it so that your body absorbs more calcium because it's on a lower gravity environment and you don't want to have weak bones? Can we start making it so that if you're born also on Mars, that maybe your body can survive with like lower oxygen and higher carbon dioxide, like different makeups? And I think we're going to start seeing that within our lifetime, within like the 15 to 20 year timeline, that we're starting to add like superhuman abilities for people that are born in different places. And that's what and I think that's just going to augment and accelerate more and more of the human expansion into space, is what I was trying to say.
Yeah, definitely. I think that's an interesting take. And I think also more not really in the center of this conversation, but I think also the acceleration and also the application of some of the methodologies which you've mentioned which are now being applied in hardware, coming from software development, are obviously also applied in biology, and how you run laboratories, how you automate laboratories, how you run experiments, and all of that on top of generative AI in the field of biology, I think is really incredible. And I'm very curious what to see.
You had your ring right on the finger for I don't know, 1 or 2 years, and you had a lot of telemetry for your body. So
that's true. Yeah.
Maybe at some point in time you can also use SIFT to understand, the effect of your training.
Yeah.
Nice. So, we are always interested also in the venture story behind it. And you raised a lot of venture capital, right? So, and you mentioned Google Ventures, etc. Tell us a bit about your fundraising story, because I think we also, I know we have some founders, also space founders, also early stage founders listening to the podcast. And it's always great to hear this experience right firsthand from you. So how was the first round and then the last rounds? How did you approach fundraising?
Yeah, definitely. I mean, it's one of those things where you definitely have a lot of doubts, self-doubt and insecurity. Did I make the wrong decision starting this? Why doesn't everyone else get this idea? And also on top of that is like coming out of SpaceX, all I had was engineering experience. I'd never been able to sell anything, never really had much experience raising money or doing any of that. So you don't realize or have that good feedback loop about what is it that's working and not working. But if you kind of take that like SpaceX mindset of like understanding more from first principles, like, hey, how do I incorporate any feedback I get and then iterate on it? I think doing that in rapid succession. That's what we did during the initial fundraise. So I left, I think like May or June from SpaceX. And then I remember I left on a Friday and we started everything on Monday. So I really had like 2 days off. And it was like a really interesting period where what is it that we were doing? I think we had an initial story. And to be honest with you just can't overanalyze it. You just have to start and you start getting feedback. And some things work, some things don't. You hear from people, you kind of have to capture all those signals, incorporate it, and just iterate really quickly. And that's why a lot of times I hear these stories about people saying, hey, I pitched like 100 people and we only on the last check we got it or whatever. And for me, I don't know if it's like really, I don't know. It feels like you're brute forcing something and maybe you should be iterating and figure out how do you keep improving, because your success rate, you should get better every single time. It's like when you're firing a gun and there's tracer shots and then like they get the shot narrower each time. That's what you want. And I would say the first round was definitely the hardest and the trickiest and the most insecurity. But at the end of the day, I think the lesson I would take away is that a lot of these VCs are, okay, there's like a lot. I can give you like a longer answer or a short answer. Do you want like a little bit like the 5-minute answer?
Yeah, we are very much interested in that. Yeah.
Okay, so I think a lot of them, you have to think also from their perspective, right? They, in order to decide to invest in a company, they have to basically spend 2 weeks to go deep dive on that company. That means that in a 1-year period, they can really only deep dive on like 25 different companies. So how do you have an interesting enough hook that they want to go spend the next 2 weeks of their life researching this? So it could be your background, it could be a really compelling pitch, it could be some really interesting data points that they weren't aware of, or it could also just have a longer term relationship where they've kind of seen your slope. Because it's much easier to invest in someone if you kind of seen them throughout their career and you see like a high slope, rather than saying you just meet someone and it's like, oh, this is really interesting, but I don't know them. I don't know what they were doing before. Like someone could look really impressive, but if they were just given like let's say they have like $10 million in revenue, but then you realize that they were given $100 million from their parents, is that really all that impressive? Is that, how impressive is that versus someone who actually had $1,000 and they grew that into $1 million? Like that's actually a lot more interesting as a slope, right? So I think it's one of those things where it's like you develop that slope, so you have more data points, you have to convince people to spend that 2 weeks. And then once they're spending that 2 weeks, I think the big thing is how do you make it simple and clear enough that people can understand, and not just for that investor to understand, but also something that they can then go take to other people on the team, the other partnership, and say, hey, this is a really interesting market with a really smart team that has like a interesting solution about how they're attacking it. I think this could be a big, and then like show a potential payoff that could be relatively large there. So I think it's one of those things where a lot of it is about how do you reduce that risk and then educate people so that they also feel like there's a lot less risk. And when I say risk, one of the things that we did was before we like really started the talking to investors, we had spoken to 17 companies and we had a big dossier. We had like, this is what this company does today. This is what these are the problems that they're running into it. These are the problems that we expect they're going to run into and why they're going to need SIFT and how much they're willing to pay. Mm-hmm. So having that research helps people get smart on that field within that 2-week period as well.
Yeah. So that was in the first round. You went in, you already had these 70 customers and, the value story actually for your product, but it was pre-product and pre-revenue, right? So what was, I'm just looking up on Crunchbase, the first round. How long did it take you to raise?
About 3 months, I think, 3 to 4 months, which it felt a lot longer. I felt like I didn't realize that's actually like pretty short. But when you have nothing and you just left your job and it seems a lot scarier, right? So let's see, it's about 3 to 3.5 months. And then we took actually 3.5 and then our existing investors within that, as we were building and shipping and they saw some interesting data points, they said, hey, the market's not good right now. Here's like another 4. So when we announced it actually shows like $7.5 million seed round, but technically it's actually like 3.5 plus 4.
Yeah. And then the next round was already 17.5, right? And then 42. And so a pretty nice trajectory. And maybe also like for this early phase, right? What were the first hires you actually hired for SIFT?
All engineering. It's just you have to go build product, right? And we got engineers that are like highly iterative, want to work with customers. They're excited about the space. So we hired a lot out of our network initially. And then over time, we one of the hires I actually think people should bring on sooner rather than later is like a people hire, like whether it's like a head of talent or a senior recruiter, someone who knows what a lot of these roles look like, because I think it can actually save you a lot of pain from hiring the wrong people. And also the cost of using, when you're starting to think about hiring like a recruiting team that says like what's good. And when you start hiring a recruiting team, you start paying like a percentage of that the first year salary of that person. And that gets pretty expensive. Whereas if you just go hire like an in-house recruiter who's very senior, not only do they pay for themselves very quickly with like 3 or 4 hires, they also are going to help you make sure that you're hiring good people, as opposed to like, I've never hired a sales leader before, so I don't know what to look like. I could be like, someone who's like somewhat salesy might sell me on hiring them. And this other person would have seen and had a lot more reps hiring. So I actually would it's like a little bit I don't think a lot of like VCs would recommend it, but I actually would recommend hiring like a super senior talent recruiter type of person in your first 10 hires.
That's also typically the better ROI than running from external recruiter to external recruiter, where you have to transport the values, the company story, etc. But maybe before we go to the ecosystem, the last question is also connected to this. In your in an interview, we have seen that you said one of the biggest differences at SpaceX was the speed of iteration. Teams moved incredibly fast, solved problems quickly, and learned by doing, which people say it's an extreme urgency, and which is the core operating principle from SpaceX. And you try to replicate it at SIFT, right? So this, like, how do you do this? How do you, when you now have roughly 90 people, how do you transport this urgency as a culture within SIFT?
Yeah, I mean, we could definitely improve and do better. But what I would say is the thing that worked really well for SpaceX is there's like a natural built-in cadence. So what I mean by that is, like, you take Dragon, there's 6 to 8 Dragon missions per year. And when you're doing development for certain features and things that are going to go on Dragon, it's either you're going to meet it by this Dragon launch, or it's going to get thrown out and it's going to go to the next launch. There's like a drop dead. This is the final date. And that cadence means that there's like, you can't just keep, I think most engineering companies, they'll have a roadmap, but they technically, even if they have 2-week sprints, like it's actually something I disagree with, but I think a lot of engineering teams still use, is like this idea that you can like roll stuff over between sprints. Like, I actually don't think that makes sense. Like, you said you were going to get this done by this date. And then there isn't really a forcing function that says like, we have to get it done by this date, or we're going to be here till like middle of the night till this thing, like if we ship this or not. And at SpaceX, it's like, well, this rocket is going. It's either on that rocket or it's not on that rocket. And I think that's like a really valuable thing. You have like these 6 to 8 periodic cadences that say that like very much are like these urgent deadlines that you have to go line up to.
Yeah. As we are approaching the end of our conversation, I would have one question which goes also beyond, again, your company and SpaceX or your background, but more into the direction of the world which you're operating in, which is the physical space, meaning that more and more hardware companies, I think, are seeing now a very bright future ahead of them, because ultimately VCs now have an easier time understanding that hardware is hard, but it also provides a mode in a world where just pure play software oftentimes is quite replaceable. So with you being right at the intersection of this shift in speed and the acceleration within the kind of like hardware startup ecosystem, and also AI and data, how do you see AI affecting the way how we build and ship new products in the hardware domain over the next few years?
So I think the biggest thing is actually you're going to start seeing there's 2 parts. One is, I think there's like the brains. I think a lot of times there's like a lot of this gets conflated, but I actually think that the brains of the hardware, like autonomy and autonomous systems, that's going to get a lot smarter, and they're going to iterate a lot faster. And you're going to have things like this reinforcement learning, and you're going to have like for example, I don't know if you ever saw like Google had AlphaGo, OpenAI had this hide and seek thing where they like play simulated games against each other, and then they start coming up with like strategies that humans never came up with. I think we're going to start seeing that, where imagine what starts happening. Let's say you have evolution, but at like rapid scale in a simulated environment. And we're going to start seeing these robots and things do things in ways that humans never would have thought of. I think that's one. And then 2 is actually, I think the hardware is going to start looking a lot different, because a lot of times we develop hardware based off of what we've you learn certain principles, like you learn things in school about structure and how, like you learn things in mechanical engineering about stresses and arches and certain shapes for distributing weight. Whereas if you actually look at a company like Divergent, that's a company, Divergent 3D. They're a 3D printing company that uses AI where they just put in the constraints. They said, hey, this like wishbone structure that goes inside this Bugatti on like the suspension, we want it to have a certain amount of like rigidity and strength, but we also want it to have like minimum weight. And you just put these constraints, and then you basically let the AI optimize for that. And if you go look at the structures of like those parts that Divergent develops for Bugatti, they look very organic. It looks like something out of a coral reef, not something out of a car or like a precision like rocket or plane. And I think we're going to start seeing a lot more organic evolution style shapes and things in the physical world that are better optimized based on the input constraints.
Yeah. I've seen, like, I was in the wind tunnel at BMW in aerodynamics more than 10 years ago, and I have seen a super smart PhD with the methods back then trying to do this, right? Like surfaces and geometries which auto optimize themselves. And I this is what makes me excited about technology today, right? I mean, I also have more like a hardware background, and we have a software company, so also at the intersection. And I think the future is pretty bright. Definitely room for a second podcast with you, I would say. Unfortunately, we're at the end, but I also hope that some listeners, we know some also space companies, executives and employees listen to this. So check out SIFT 100%. And thanks a lot for the podcast. We always ask our guests to recommend the next guest. So Karthik, like, who should we have as a guest in the podcast from your network?
Yeah, I think I don't have a specific person, but I think there's probably more to unpack on the way that biology is changing to support like human interplanetary travel. There's something I would say in like the science space.
Yeah,
it's interesting that you say this. We had one podcast with Yuri Microgravity, which is also doing biological research in zero gravity.
Yeah.
But now on the design, like, we need to get someone in who is actually working on these long duration missions to other planets.
Yeah. So if any of the listeners has any guests who we should bring on, let us know. You can reach us on LinkedIn and obviously also throughout the email on our website. But Karthik, I think that's a great idea, and we want to do this. What's the best way how people can get in contact with you or with SIFT?
Yeah. So the best would be on our website, honestly, and just drop a little memo saying that you heard about me on the podcast. I actually do still get all those inbound if you go to our website, I still see it. So it pops up in Slack. And if you said that it was, you heard about me on New Space Vision, and
nice.
Perfect.
I'll happy to chat.
Perfect. Well, that's a great call to action to all the listeners. Thank you very much, Karthik. That was really amazing. Super interesting, and I think a little bit out of the ordinary what we're talking about. Typically, we talk about the satellites, the missions, or whatever, and here really too, which enables us to move quicker into space and within space. So thanks so much for joining today. To all the listeners, thanks for tuning in again. And yeah, Karthik, all the best to you, and we are very much looking forward to seeing where SIFT is taking the observability space in hardware development. Thanks for being here.
Awesome. Great. Thanks for having me.